Now we're going to continue with section 4.4. In this section we were solving radical equations. So we're going to do the same concepts here, but we're just going to start out with maybe rational exponents in some problems, and we're also going to look at how it works if you're solving an inequality. So in the first one, in number 11, so this is page 2 of your note-taking with vocabulary for section 4.4. Number 11, we're asked to solve and check our solution. We have 1/2 times x to the 5/2 power equals 16. So the first thing that I need to do is that, remember the directions for part 1 said that you isolate your radical first. So that means here I need to isolate that x to the 5/2 power first. To do that, I can multiply both sides by this 1/2, or multiply both sides by 2 to get rid of this. So 1/2 times 2 is just 1, so that gives me x to the 5/2 power equals, and then 2 times 16 is 32. So I just multiply both sides by 2, the reciprocal here. And then, how do I go from, I've got x to the 5/2 power, how do I get x to the first power? Well, you have to remember rules for exponents. Rules for exponents tell us when you raise a power to a power, you multiply your exponents. And our job here is to figure out what can I raise this side to get x to the first power. So I want x to the first power. I need to raise both sides of this to some power so that I end up with x to the first. So what should it be? To get x to the first power, we want to have an exponent of 1. So to get an exponent of 1, I can multiply by the reciprocal of 5/2. So if I multiply 5/2 times 2/5, that would give me a 1. So that tells me I need to multiply both sides of, this tells me that I need to raise both sides of this equation to the 2/5 power. That's the reciprocal for 5/2. So raise both sides of your equation to the 2/5 power. So 2/5 and 2/5. Like that. Okay. So 5/2 times 2/5 is 1. So we have x equals, okay? And you always have to stop and ask yourself, sometimes you have to do plus or minus. Remember, sometimes when you apply a radical to both sides of your equation, you had to do plus or minus. Like if you take the square root of both sides, you have to do plus or minus the square root of that constant. If you're doing any even root, a 4th root or a 6th root or an 8th root, etc., you do plus or minus that square root or that radical. Because this denominator is a 5, that means I'm doing a 5th root. And with that being an odd root, I don't have to worry about the plus or minus. So because this is the 5th root, and that's an odd index, I don't have to worry about plus or minus in this one. So now we just need to simplify 32 to the 2/5 power. Okay? Well, we've been doing factor trees, and we know that we can break 32 down to 2 to the 5th. So I can say 2 to the 5th raised to the 2/5 power. And now because I'm doing a power to a power, I need to multiply my exponents. 5 times 2/5 gives me 2. So this is 2 squared, or 4. So we got x equal 4. We're also asked to check our work. So we're going to put 4 back into the original problem. So when I check it, I need to do 1/2 times 4 to the 5/2 power equal to 16. So starting with, do your exponent first. So 4 to the 5/2 power, you can think of that as, you can use your calculator at this point if you'd like. But I know that this is 2 squared to the 5/2. I'm just going to use my rules for exponents. And then when I do a power to a power, I multiply 2 times 5/2. So that means my exponent is a 5. So I've got 1/2 times 2 to the 5th. 2 to the 5th is 32. So 1/2 of 32. Half of 32 is 16. So it does check. My answer is x equal 4. Alright, so that is number 11. I'm going to go down to number 13 next. So when you're doing a radical inequality, it's very much like solving a radical equation, but there is one extra thing that you have to consider. You know that you know that when you do a square root or any even root, that the radicand, the inside, can never be negative because because that would send you into imaginary numbers, and we're not dealing with that here. So you got to make sure that the inside of this radical with this square root, or if you have a fourth root or sixth root, make sure that's never negative. It always has to be positive. So we're going to have a little bit of an extra piece to this one. But I'm going to start just like I would with an equation. My first step is to isolate the radical. So to do that, let's subtract 3 on both sides. Negative 1 minus 3 is negative 4. And now I can divide both sides by negative 4 here. Remember, when you multiply or divide an inequality by a negative number, you're going to flip your inequality symbol. Okay? I just sang a silly song to my 7th graders this past week. I'll share it with you too. If you don't like to hear me sing, you can just fast forward through this. But I told them that when you multiply or divide by a negative number, pop goes the symbol. So if that's something you have trouble remembering, that might help you. So I'm dividing both sides of this by negative 4. So negative 4 by negative 4. And that's why I flipped my inequality. So this gives me square root of x minus 1 less than or equal to positive 1. I've isolated the radical, so I'm going to square both sides now. Squaring both sides gives me x minus 1 less than or equal to 1. And add 1 to both sides. X is less than or equal to 2. So that's the first part of it. We found that x has to be less than or equal to 2. But we also have to make sure that our radicand, this x minus 1, is never negative. So the second piece of this is to also, so this was step 1. And then step 2, we need to make sure the inside, the x minus 1, make sure the radicand is always always non-negative. Non-negative means that it can be positive or it could equal to 0. So we'll say it's got to be greater than or equal to 0. Add 1 to both sides. X has to be greater than or equal to 1. So we have found that x has to be less than or equal to 2. At the same time, it also has to be greater than or equal to 1. So how can we say this as an inequality? Well, 1 is smaller than 2. X should be in between. If you look at this backwards, 1 is less than or equal to x. 1 is less than or equal to x. X is less than or equal to 2. So that's how you can say it as a 3-part inequality. Interval notation, which this book does not include, but I'm going to because you'll need it for 171. Interval notation would be square bracket 1, comma 2, square bracket. Okay, so either of these would be correct. So that's number 13. All right, pause it if you need to continue copying. I'm going to keep going. Number 15. We've got 2 times the square root, 3/4 x, and then on the outside of the radical is a minus 39, less than or equal to negative 25. Okay, so in this one, again, isolate the radical. This means 2 times the square root because it's sitting on the outside of it, so just be careful that you're not reading that wrong. I would start by adding 39 to both sides. So I've got 2 times the square root of 3/4 x less than or equal negative 25 plus 39 gives me 14. And then I need to isolate the radical, so divide both sides by 2. Square root of 3/4 x less than or equal to 7. Now that the radical is isolated, I'm going to square both sides. So if I square the left, I get 3/4 x. Square the right, that gives me 49. So if you need an extra step in there, just fill it in. Alright, and then to solve for x, I'm going to multiply both sides of this by the reciprocal of 3/4. So multiply both sides by 4/3. That'll give me x is less than or equal 49 times 4/3. And that's going to give me a value of 65.5. Okay, so we're 65.5. Again, because this is an even index, so the square root, you have to make sure that the inside is positive. So this was step 1. We've got a step 2. Now, alright, let's keep going. So for step 2, the inside of the radical 3/4 x has to be greater than or equal to 0. So solving this, multiply both sides by the reciprocal of 3/4. X is greater than or equal to 0 times 4/3, but it's still 0. X is greater than or equal to 0. So x has to be positive, and it has to be less than or equal to 65.5. So that means x has to be between the numbers. So 0 is less than or equal to x, less than or equal to 65.5. Or you could say square bracket 0, and I'm using the square bracket because it's got the equals with it. If it didn't have the equals, I would be using I'd be using parentheses. 0 to 65.5. Square bracket. So either of these is the correct answer. I skipped over number 14 because I wanted to mainly do the odd ones, but let's go back to number 14. I want to look at that one with you as well. So going back to number 14. Also, when you're doing this, I should have mentioned this probably earlier, but these problems do not give you enough space on your page, more than likely. I did it on mine, but it's very tiny and squished in, so it might be better to do it on a separate sheet. All right, but number 14, we've got the cube root 2/3 x plus 1. This is all inside the radical, less than 6. Okay, in this one, we do not have a square root, we have a cube root. So we're going to be cubing both sides to eliminate that radical. So you'll cube the left. When you cube your cube root, it will pop out, it will just undo itself, and the inside, the 2/3 x will pop out, or 2/3 x plus 1. So 2/3 x plus 1 is less than 6 to the 3rd power. So 2/3 x plus 1. 6 to the 3rd is 216, and then subtract 1 on both sides. 2/3 x is less than 215. Multiply both sides by 3/2. X is less than 215 times 3/2, and that will give me 322.5. Okay. Now, that was step 1. Do I need to do step 2 this time? Remember, you had to do that to make sure that the inside of your radical was never negative. This is a cube root. Can I have a negative inside a cube root? Actually, yes, it's okay. So because this is an odd index, it's okay to have a negative inside my radical. Think about it. You can take the cube root of -8 because it's -2 times -2 times -2. It's only those even indices here where you cannot have a negative inside. All right, so this time I don't have to worry about the inside of the radical. It can be negative. So this is all I have to do. So my answer this time, it would be x is less than 322.5, or you could say parentheses negative infinity to 322.5. Parentheses. And this is parentheses because there's no equals with this inequality this time. And then we're going to look at number 16. It says in basketball, the term hang time is the amount of time that a player is suspended in air while making a basket. To win a slam dunk contest, players try to maximize their hang time. A player's hang time is given by the equation t equals 0.5 times the square root of h, where t is the time in seconds and h is the height in feet of the jump. The second place finisher of a slam dunk contest had a hang time of 1 second, and the winner had a hang time of 1.2 seconds. How many feet higher did the winner jump than the second place finisher? So let's look at the winner and the second place. Okay, for the winner, it said that the winner had a hang time of 1.2 seconds. So go back to your equation. You've got t equals 0.5 times the square root of h. And the 1.2 seconds for the winner goes in for which variable? Well, t is time. So put 1.2 for t. And solve for h. So you would divide both sides by 0.5. 1.2 divided by 0.5 equals the square root of h. And that would give me 2. I'm sorry, 2.4. 2.4 equals the square root of h. Square both sides of that. So 2.4 square equals h. 2.4 square would be 5.76 equals h. And then for the second place finisher, their hang time was 1 second. So put 1 in for t. That was 1 second. So 1 equals 0.5 times the square root of h. Divide both sides by 0.5. 1 divided by a half is 2. Square both sides. So you get 4 this time. So the winner had a hang time of 1.2 seconds, and this is the height that the winner reached. The height here was 5.76, whatever it was, feet. Yeah, 5.76 feet. This one reached a height of 4 feet. So the difference in the height would be 1.76 feet, or 1 7600 feet. And that concludes our notes for section 4.4. This is your homework assignment for section 4.4 part 2. I'd like you to work these out on a sheet of notebook paper and copy each question. Make sure that you copy question number 3 on paper before you work through it. For number 1, solve the equation, check your solution. You have 2 times x to the 2/3 power equal 8. Number 2, solve the inequality. 4 times square root of x minus 2 is greater than 20. And for number 3, the length L in inches of a standard nail can be modeled by L equal 54 times d to the 3/2 power, where d is the diameter in inches of the nail. What is the diameter of a standard nail that is 3 inches long? So have these ready to hand in at the beginning of class.